Hey guys, welcome to the Scholar Online YouTube channel, the channel that is all about learning, okay? In this channel, we make a lot of videos on web development, WordPress design, e-commerce development, Python development, and a whole lot more. We will take you through the process of everything we're teaching you from beginning to end, step by step, so that you can follow along and build as we build, all right? If you're new to this channel, please make sure that you hit the subscribe button. The subscribe button is going to be red right underneath the video that you're watching, and like this video and comment on these videos. Let us know what works for you, what doesn't work for you, so that we can create content that is more relevant to what you guys want to watch, okay? Also, underneath the video that you're watching, there is that show more button underneath the description. Please open it up and have a look at some of the links that we've created for you. Every time that we make a video, we will add all the useful links underneath it. So if you hear me saying in the video that I'm going to link it in the description below, that's where you'll find the link in the description underneath the video, all right, for more information to help you learn along, all right? And a lot of the videos that we make, also we will create timestamps because our videos are long. You don't have to watch the entire video. You can go through these timestamps and read which part of the video you are interested in watching. Click on the timestamp and it will fast forward you to that part of the video, and you only have to watch that, all right? And we also have linked in the description below our social media channels, so feel free to follow us on Facebook, on Twitter, on Instagram. We've got our website right there, and if you want to get in touch with us, my email address is also available in the description below. So let's start learning. In this video, we're going to spend some time discussing a blockchain programming with Python. I'm going to give you the very high level basics, at least to get you started, or, sort of get you thinking if this is the kind of field that you want to get involved in or get interested in and learn more about it, because there's definitely much more to learn. But I have to mention now that blockchain programming is probably one of the most complex type of programming that I've done in my career programming. But there are steps to follow, and as complex as it is, it's definitely not impossible. And I honestly believe that there is a huge potential when it comes to blockchain programming. I think a lot of people misunderstand what blockchain is. You get a lot of people that think blockchain is Bitcoin. So I'm going to try and explain a lot of that to you in this video. And at least by the end of the video, you should be able to talk the blockchain lingo, all right? You should be able to sit in front of people that are technically inclined in blockchain, and you should be able to sort of understand what they're talking about and talk the lingo. But if you want to learn more, there's definitely much more that is available to learn when it comes to blockchain programming. So the structure of this course of this lecture is going to be in this format. I'm going to start by giving you a very high definition of what is a blockchain, and we'll talk a little bit about how you put together the chains of blocks and blockchain ledger technology and the differences between what a blockchain and a database is, so that at least you're not confused about, if somebody asks you why don't you just use a database for that, right? You can answer that question. And then finally, I will do very high level, Python code for, putting together a block so you can understand and put all of this theory that I'm going to give you into context and sort of understand from a practical perspective. Because after all, we are a programming, YouTube channel. We are a, development YouTube channel. So we can't just, be talking theory the whole course without a little bit of programming. So we'll end off with some code, and you can, get to see what I'm talking about when I'm talking about the block. What is a block? So let's get started. High level. Somebody stops you in the middle of the street. What is a blockchain? What do you say to them in very simple English that even a 2-year-old can understand? First and foremost, a blockchain is a database. Okay? I will qualify that a little bit later on. But first and foremost, a blockchain is a database. We're going to expand on that. It is also a ledger. Okay, so it is a database that is in a ledger format, in the sense that information is recorded into it one step at a time, like a ledger. Because if you had a ledger, you would have, this is the first transaction that happened, or this is the first state of this ledger, and then something happens, you come and you record the next state of the ledger, and so forth and so forth. And over time, that ledger grows with more and more information, all right? So in very high level sense, that is what a blockchain is. It is a database that is in the form of a ledger that sort of information gets recorded into it, data gets recorded into it, one step at a time. As information gets added, it gets added. So by definition, it is a ledger that is constantly growing. All right. So over time, you are growing this ledger or this database with adding more and more information into it as you go along. So in very, very basic terms, that is what a blockchain is. All right. But let's expand on that a little bit more. All right. It is obviously a little bit more complicated than just saying that it is a database or a ledger, right? It has some technology that is built into the database itself that governs the integrity and the reliability of that data. This is why you will hear the words like trust getting put into blockchain and it being like a trust based technology or a trustless based database, because it can allow multiple people to manage that database who don't trust each other, but they can be secure that the information that they stored in there is reliable because of the technology that governs how that information is structured. And that's what we're going to get into explaining later on, the technology. So the main thing to carry on from this slide is that as much as it's a database and as much as it's a ledger, it's not a simple database or a simple ledger, okay? It has very advanced technology that involves very high level cryptographics that manage how information is stored, which means that you can't just add information as you wish. I can't just I want to add this to that database. Let me go edit the way you would do with a normal database. The way you add information is structured in a systematic way that you have to the database has to check who you are. You have the right to add this information to it. All right. You have the signature to add this information. All right. And it records you adding that information. And once you've added that information, it is going to be very difficult later on to remove it. This is why instead of deleting and updating the database, you will just add another block to change the state, all right? And the information that you added before will always be there. This is how the structure is. It is slightly different from the normal database where, I could put a row and a column, right? And I could have a row that says, let's say you have a database that says, my name, a database that is, managing like, people's information, right? And then you put a row in the database that says, okay, we're entering a person into the database. That person's name is Scholar, their surname is online, and their ID number is 12345. All right. Tomorrow, if it was a normal database, you could technically go in there and update that information and say, okay, no, Scholar Online has changed their surname. Their surname is now Scholar, Live, for example. And you could change that and the normal database would work like that. In a blockchain, okay, you wouldn't do that, right? In a blockchain, once you've entered information and you've said, this is the name of that person is Scholar, their surname is online, and the ID number is 12345. If you want, you can update the state by adding a new data, which means that block remains that was always there. You would enter a new block that says, okay, now we have Scholar Live and the ID number is 345678910. Connect that to the initial block where you said Scholar Online, and anybody who goes and queries that blockchain will always see what was there before and that what was there that you updated now. And they will also be able to see that you have the right to update that information, you have the access to update that information. They'll be able to see that you are the person that signed for that transaction and you have the right to sign for that transaction based on your access rights on that database. So there's much more involved when it comes to a blockchain type database because you have to manage the access rights, you have to manage the information that gets put in through signatures, making sure you know who is signing for what information, and that information can never be changed. It can only be amended. All right. It can only be amended over time. So I think that's enough for now. We're definitely going to get more into this later on. Okay, because I don't want to confuse you too much on the first slide, but I just wanted to close off here by starting to say that a blockchain is not Bitcoin, by the way, and Bitcoin is not a blockchain. Bitcoin is a cryptocurrency that uses blockchain technology, all right, in its database or ledger management, all right? So it is a cryptocurrency that uses the technology of blockchain. Yes, the person that invented the blockchain is also the person that invented Bitcoin. And he invented the blockchain as a technology that powered Bitcoin. But after that, people looked at this and said, hey, actually, this technology is quite amazing. We can use it for other things as well. All right. So yes, you can use it to power a cryptocurrency. All right. In the sense that you can manage the ledger of the cryptocurrency and who has how many Bitcoins over time. All right. So it is ideal for that. But the technology in itself, you can use to manage anything. So the data that is stored in the blockchain can be transaction data for a cryptocurrency, but it can also be any other data. You can store contracts in there. This is how smart contracts were introduced. You could store a contract in a blockchain, all right, and it will always be managed according to the rules of the contract as you set it up, because you'll never be able to change that information over time. You can only amend the data as you go along, all right. So as a technology, it can power a lot of things. And a lot of industries and companies are starting to realize, hey, we can actually use this technology to manage ledgers between our organizations so that we can cut out the middleman, because the technology itself is reliable enough that we know that the information, the integrity of the information that is stored in there is going to be, trustworthy because of how, encrypted and how sort of advanced that technology is, all right? So the difference between Bitcoin and blockchain is that Bitcoin is a cryptocurrency that uses the technology of blockchain to power it. But that technology of blockchain can be used to power any other thing that you think about. All right? We'll get into that later. So let's go back to where we started, right? So let's go into the chain of blocks, okay? So I think we have a high level understanding of what is a blockchain now, all right? So let's think about it, another definition, and think about it as a chain of blocks, right? So remember what I said, that as opposed to a normal database where you can update, delete information, right? When it comes to a blockchain, you can't update and delete information. You will have information, let's say you've stored in block 1, all right? And tomorrow, let's say a different transaction happens and the state of the blockchain changes, all right? You need to add new information, right? To update that information. You need to add new information to amend on top of that old information, and you're going to create block 2. And that block 2 is going to be connected to block 1, all right? Because it's going to start forming a chain. This is where you hear that word blockchain. Blockchain is technically a chain of blocks. Every time you are adding a new block to the chain, you are adding a new data that is the updated data, right? And over time, you would have to analyze all the blocks to determine the current state of the blockchain. But as you add more information into the blockchain, it is basically just amended on top of the last block to create a new, set of transactions or a new set of data that you add on, all right? And each and every single block, you'll hear about this thing called the block hash, and we're going to get into more detail. You'll see when we start to write the code for it, how that is developed. But basically, each and every single block has what we call a block hash. And a block hash is sort of like a signature of the data. All right. So if you think about data having a signature or a fingerprint, each and every single individual in this world has a unique fingerprint, okay? And you can never adjust a person's fingerprint. You can even use the fingerprint of a person to identify a person. If you came across a fingerprint, you would be able to say this fingerprint belongs to that person if you have that person's fingerprint in your database, right? So think about data in that sense, that data has got a signature or a fingerprint, all right? So if I have data that says my name is Scholar Online and I signed that data, I can create a fingerprint for that data. And if I change that data and I say my name is Scholar Live, that fingerprint of that data will be different. All right, so every time we add data into the blockchain, basically we sign that data and we create a data fingerprint, and that data fingerprint is known as a block hash, and that block hash is used to identify that block. This is why it is very difficult to adjust and change and edit the data inside of a block, because if you change the data inside of the block signature would be different and it would not match the signature that you had before. So how we manage the integrity between block and one block to the next one is that we will create the block, we will create the hash, and we will store that hash. All right. And then the next block will store that hash, and that hash will also be connected to the previous hash, which means that if anybody came and adjusted the data in block 1, the hash in block 2 will also be different, and that chain will be broken. All right. So to maintain the chain, the data can never be modified over time. And how would you know that the data is modified anyway? Because if you changed the data here and this hash is different, you could just propagate the change and change all the hashes, right? And then you wouldn't know that I changed the data in block 1. What would prevent you from doing that? What prevents you from doing that in the blockchain is now what we call, if we go back here, is what we call distributed ledger. And this is really what makes blockchain unique, is that it's not just a ledger. It's not just a chain of blocks. It is a distributed ledger. Because if it was just a chain of blocks, what would stop you from adjusting the data in block 1 and then just letting that change propagate so the chain remains intact because you reproduce the hashes as you go along and no one would know that you've changed it, right? What makes the difference is that it is distributed across many peers or many members of the organization or the consortium of the blockchain, right? So the blockchain is data that is stored across many locations or many peers. So peer 1 will have a copy of that chain, and peer 2 can be another person. They'll have a copy of the same chain, and peer 3 will have a copy of the same chain. And the more peers you have in a consortium of the blockchain, the more secure that blockchain is going to be. If you think about Bitcoin, I mean, there's thousands and thousands, hundreds and thousands of peers, right? These are all people who have a copy of the blockchain, and they're all maintaining the copy of the blockchain, which means if I adjusted information on my blockchain and I have a copy of it and I changed it and I tried to sort of fool everybody in letting people think that this is the new data and I propagate my chain is not going to look the same as other people's chains, right? Because they'll have a copy, they have a copy. Whatever I do to my chain will be different from the other one. So when it comes to voting and to figure out what is the correct chain, my chain will be kicked out because it will be different from all the other chains. And that's what makes it so unique in that, in the sense that the chain is not just kept in one place. It is kept in multiple peers. It is stored in multiple locations, which means these multiple locations have also a technology in how they compare the chain with each other to make sure that they all have the correct chain. So if I have a chain that says X, this peer has a chain that says X, but peer 3 has a chain that says Y, all right? When we are trying to figure out what is the correct chain between all of us, all right, we are going to vote and the majority is going to rule. So the majority that has the chain that looks the same, we're going to say, well, that's the correct chain. Everybody throw away your chain. This is the correct chain that we're working with, all right? And we're going to then update everybody's chain to the one that is the most, that is similar across all the peers. This is why you'll hear words like, in Bitcoin, words like a 50% attack. It's a risk for, having one company having more than 50% of the hash power or whatever inside of the network, because technically if you could be more than 50% of the nodes, you could adjust the entire chain to what you want it to be. All right, that is why a blockchain is more secure the more peers that it has. It's the same thing as a democracy. Think about it like a democracy, all right? A democracy is more secure if there's more people voting, all right? Because more people, more opinions. But if more people vote the same thing, that must be the correct thing, right? And this is very, very high level, I know, all right? But just think about when it comes into a blockchain, you have a database. That database is formed into a chain of blocks, all right? And that chain of blocks is distributed across many peers, all right? And this is how the data integrity is kept. It's kept across the chain of blocks, but it is also kept across a multiple, network of peers who maintain the same chain of blocks to maintain the integrity of the data, all right? So this is very, very high level, and if you're getting confused, trust me, blockchain technology is really, really complex in terms of understanding the concepts. This is why at Scholar Online we have a full plus 10-hour course just going through blockchain technology and the coding for it. And if you want to learn more about what I'm explaining here and you want to take time, all right, feel free to go and have a look at that course. I will put the link in the description below because it really takes you through the concepts slowly, one step at a time, because it is really complicated. But you need to give yourself time if you want to get into this field of study. I mean, I would say at least 2 to 3 months that you put time aside, go get the course, think about how much hours you're going to give to the course on a daily basis so that you go through the material, regularly, and you need to have the time to do it. But if you go through the material regularly, you will understand these things at the end of the day. All right. So let's continue now with what we're doing here today. Now let's go into a blockchain versus database. I used to get this question all the time when I started in blockchain technology. And sometimes I would have no answer, because I would say to me, but if what you're explaining to me, I can just do that in a database. Why do I need a blockchain? All right. So I'm going to give you the correct answer and how you answer this question when somebody asks you, what is the difference between the blockchain and just a database? Why can't I just build a cloud database on, AWS and just use that instead? Well, I can have multiple peers on AWS, and then I can have my blockchain. Why can't you just do that? Let's get into it. Number one, a blockchain is distributed, right? Remember what we explained when we talked about this distributed ledger, the fact that you will have the data not in one peer. So think about a peer as a server or a node. Okay, you will have that blockchain not just in one peer, but in multiple peers. And these peers must not be related or do not have to be related to each other. They can be peers sitting in different parts of the world, like in the Bitcoin blockchain. There's thousands and thousands of peers all over the world. They're not related. They don't know each other. They don't even have to like each other. All right. But they are maintaining the same blockchain because they are governed by the technology, by the distributed technology of how that information is kept the same across all of them. So a blockchain is distributed, whereas a database is not distributed. If I have a database on an AWS server, that's where it's sitting. Then somebody will say, but I could have 2 or 3 servers. I could buy 3 or 4 servers all across the world, and then I could create backups on all these servers. So if somebody changes information on server 1, the other backups will kick in. Technically correct, right? But the difference between you doing that is that you are one organization. So you are one organization, and as one organization, you only need one IT manager to go rogue, and they can access all your servers because they technically belong to you, right? So if somebody wanted to affect your data integrity, they could technically do it if they have access, because everything is still centralized. Even though you are creating a pseudo decentralization, it's still centralized because it's one organization. So it's not real decentralization, it's fake decentralization. So that is the difference between saying that you are creating backups. If I wanted to attack your system, and I could attack your backups as well, because they technically belong to you. I only have to compromise one IT manager and steal all his passwords, and I can access all your backups as well. So think about the fact that in a blockchain, the peers are not related to each other. The peers are truly decentralized. Okay, so a peer, even if I attacked one peer, I don't have the access to another peer. Okay, if I wanted to really attack something like the blockchain, the Bitcoin blockchain, I would have to attack all the peers on the blockchain, and they're not related. They're in different parts of the world. How will I find them? Whereas if it was one organization creating backups, it's easy. I only have to compromise one IT manager, and I can get access to all your data, including the backups. Number 2. The difference between a blockchain and a database. The blockchain is controlled and managed by, you'll hear a lot about this cryptography, and you'll hear a lot about what they call elliptic curve cryptography, and that's what we're going to deal with in what I'm going to be teaching you in the next sort of series of lectures. We're going to talk about how data is signed, how we create that data signature, okay, and how we can confirm the integrity of the data by comparing the signatures. And we're going to talk about how to produce those elliptic curve cryptographic signatures for the data and for the transactions, because they're on 2 levels. Every time you add a new transaction, you have to sign that transaction, and then every time you create a block, you have to hash the block. So there are 2 layers of protection in the blockchain, whereas the database doesn't have that. Well, you could argue, yeah, you could build it into it, but it's not always there, right? The blockchain has all of these layers built into the architecture of the blockchain. So the security of it And the integrity of the transaction and the integrity of the block is built into the design of the blockchain, which means that for you to use the blockchain, you have to play by the rules of signing the transactions and signing the blocks, the hashes. That is a part of the design of the blockchain. Whereas in a database, I've built a database on SQL, all those sorts of places. As a designer, you have to think about the security yourself. And you have to write the code to do this yourself, to ensure this data integrity. If you wanted to hash the data, if you wanted to, you would have to write that code separately. It's not inherent in the design of the database. You understand what I'm saying? So this is a huge main difference. This is where the security comes in, right? This is where the security comes in the sense that even the data integrity is part of the design of the blockchain, whereas in a normal database, it's not. If you had to do it, you would have to write that whole boilerplate coding to do it yourself, and you would have to know what you're doing anyway, right? And a lot of people don't. So that is another main difference into it. And so it makes the blockchain more secure in the sense that if you had to now hack a blockchain, if you have to hack a blockchain, there are two ways to hack a blockchain. Two ways. It's not impossible. It is just very hard. But there are two ways to do it, all right? And I'm talking about a simple proof of work blockchain like the one Bitcoin is based on, right? There are many types of blockchains that have come up since then. But let's focus on the traditional blockchain, which is the proof of work, the type that Bitcoin is based on. There are two ways to hack that type of a blockchain. Method number one is that you have to do what they call the 50.1% attack. You hear about it a lot in blockchain, in Bitcoin circles, right? 51% attack means that if one person could take over more than 50% of the hashing power of a blockchain, they could technically take over the blockchain. All right. This is because of how the sort of the voting happens, and the consensus happens when imagine parties coming together in a group to vote to say what is the correct method, what are we going to do now, right? If you had technically more than 50% of the people, you could take over the vote. Right? Even in a normal democracy, that's what happens. A governing party has to have more than 50% to govern. So if you could technically have more than 50% of the hashing power of a blockchain, you could govern that blockchain. That is the first weakness of it, right? But to have more than 50% hashing power is not really that easy, especially on a big blockchain like Bitcoin. But that is the first method in which you could technically hack that blockchain. The second method that you could hack the blockchain is if you could break the encryption of the blockchain, because everything is encrypted with a 256-bit encryption. This is the encryption that creates the data signatures. This is the encryption that creates the transactions and the hashes. So if you could hack that encryption, all right, if you could break that encryption, and by the way, the bit encryption that's used on Bitcoin is sort of military grade. It is really one of the highest. It is very high level encryption. All right, you would need like a supercomputer to hack that type of encryption. This is what's called a brute force attack. All right, or you would try all the possible combinations until you find the right one that that could hack it. And even then, you would be hacking one transaction at a time or one block at a time. All right. So if you're really smart and you had, and I think it's not possible, I don't think anybody has done it yet, but if anybody could do it, they would have done it by now, considering the amount of money that is in Bitcoin right now, right? You only have to hack, if I could hack 256-bit encryption, I could hack the cryptographics behind it. You only have to hack one wallet, right? You only have to hack Satoshi's wallet that has more than 1 million Bitcoins, right? And you would be like super rich. And anybody who could do it would have done it already. So I don't think it's possible with the technology that we have now. But apparently, theoretically, it is possible with supercomputers. It is possible with, what they call quantum computers, but I don't know, we haven't seen anything of that nature yet, at least not in normal circles, because in my personal opinion, I think if it was possible to be done, it would have been done already, considering how many sort of cryptocurrency sort of exchanges have been hacked and things like that. Somebody would have hacked Satoshi's wallet by now if they could hack the cryptographics behind Bitcoin. And by the way, those are the only two ways to hack a blockchain. You'll hear people say, oh no, but they hacked Binance, or but they hacked that exchange. Hacking an exchange is different from hacking the blockchain, because hacking an exchange, you're basically just hacking a person and then you get access to their Bitcoins in that exchange, right? It's not the same as hacking the blockchain, right? So two ways of hacking the blockchain: 50% attack, or hacking the actual cryptographics, which I don't think is possible anyway right now with the technology we have, right? And with a database, well, there's many ways to hack a database. You know how you hack a database? You hack a person. You hack a person. You go, you hack the IT manager's computer. You put a bug on their computer and you've hacked that database and you've hacked that whole company, right? It's so easy to hack a database. That is why almost each and every single company has been hacked. That is worth hacking has been hacked. Every exchange that is worth hacking has been hacked because it is easy to hack a person, right? So that is the difference between a blockchain and a database. Anybody asks you, that is the answer that you give them. Now, the block. We're going to go into a little bit of coding now. We're going to go into a block. We're going to go into building a block, all right? I think I will use something that is very, very simple. I'm going to use the simplest database that you can use when you're writing Python code, and that is the Google, what do they call that? The Google Firebase thing. I've been wanting to do this on this channel for a long time. If you don't want to build your own database from scratch, you can always use Google Firebase, and I'm gonna test it out here today on this online tutorial. We're gonna store our blockchain on Firebase, and we're going to build just one block to get started because I don't want this tutorial to be very, very long. And I'm going to show you how to, all the things I've explained, right? The block index, how to create a hash, and we're going to talk about something they call a block nonce, all right? And I will show you how to calculate a nonce and the data that goes into a blockchain, okay? Like I explained, this data can be anything. It can be anything from a normal dict object, it can be a transaction, or it can be a contract, all right? But today we'll keep it simple, and we'll just store like a dict object of data in there. And then finally, we'll have a timestamp and we'll create a block. And then I will show you how to create one block and then how to create two blocks, where now the second block connects to the first block. And if you can create two blocks, you can create a blockchain. All right, so I'm going to do that in the next, just in the next bit. We'll pause it here, and then when we get back, have your Python ready. I'm going to be working off a virtual private server, so get your private server ready. That's where we write the majority of our code. If you don't have a Google account, get your Google account ready as well, and open up a Firebase, Google Firebase, because we're going to create a project there, and then we're going to get started in a bit. Let's get started with some blockchain programming, okay? Where we left off, I was going to show you how to put everything that I've taught you, especially with respect to the block, into some Python code. And so you can learn how, for example, you would want to build a block that would go into a proof of work type of blockchain. That's very important. Nowadays, there are many types. I mean, if you think about what's available out there, there is lots of types of blockchains, and we're going to be focusing on proof of work type of blockchain in this course. All right, so what you need to get started, I've already created my virtual environment over here. So log into yours, make sure you are in the server that you want to, you're in the location that you want to be working from, and create a virtual environment, whatever you want to call it. Create one so that you can load your Python libraries into that Python virtual environment, and make sure that it is activated, okay? If you're not sure how to do that, check some of our previous videos on how to set up a Python development environment. We've got videos on that. We've got videos on how to set up a virtual private server, or you can work from your own computer. It doesn't really matter. Wherever it is you're working from, make sure you've got Python installed. Make sure you've got virtual environment active, or otherwise perhaps you're installing the libraries in your whole Python or computer, which is not recommended, but just make sure you're ready to go as far as Python code is concerned, okay? And then we're going to start with Firebase, all right? So on Firebase side, Firebase is a really nice product produced by Google that allows you to create a database on the cloud, and they build a database for you, and it's basically structured like the way, if you've worked with Rethink database, and the way if you worked with MongoDB, sort of like it's built like, it's sort of like a dict object. So as opposed to traditional SQL type of databases where you have to define rows and columns, and you have to define what data goes into the column beforehand. So if you're only going to put a string in a certain column, you have to define ahead of time that this column only takes strings and this column only takes integers, this column only takes, and this is really a rigid way of programming. And it works in some cases if you already know the structure of data that you're going to get, but sometimes it's a bit of a pain in the arse if you're trying to work with sort of dynamic information. So the Google Firebase database is built in that format that allows you to build your database like in dict objects, right? Where you can save an object. You don't have to define ahead of time what type of data goes into it. You sort of just give it the data and it saves it. If it's a string, it's going to be a string. If it's an integer, it's going to be an integer. And then you call it back based on the object that you saved it at. And the thing with Google Firebase is that then each and every single item is saved sort of like in a nested format, in the sense that your top table, you need to always know what reference goes into that table, and the data itself can be anything, and you can have layers and layers of references, but you have to keep track of your references inside of your code so that you can be able to either edit or call back that information later on. Okay, and the other nice thing about the Google Firebase is that it has a front end, which is your Firebase endpoint platform, where you can log in console and you can even see your data in real time from that end. You can delete it, you can edit it from that end outside of your code, although I don't recommend it, but you can do all of that. Okay, so to get started, go over to firebase.google.com. You must have a Gmail a Google account in order to access it. If you don't have one, it's very easy to create. You just create one, and then you will be logged in, and then from here onwards you can start programming. And it is also interesting that they allow you to program for free, and you can build databases for free, but of course it's limited. Okay, this time I'm not going to start with the pricing, but if you want to have a look at the pricing at the top of the, go and have a look at it so you can figure out what you're going to be paying. But Firebase is really flexible, that for development purposes, you can do a lot for free before you have to pay for anything. All right, so always check the pricing before you get started with any software, as far as I'm concerned, because once you've developed your code on that platform, and then you start growing, and then suddenly the pricing hits you, you can't change your code at that stage. So you need to know what you're getting yourself into before you build on it, right? Personally, I would rather code my own database, but for the purpose of this tutorial, because we want to make it go quickly, we will use Firebase. All right, so when you get here and you go on firebase.com and you're logged in, you can go into your console and you're going to create a new project to start working from. Okay, and it's very simple how to do that if you're working on a web platform. All right, so when you get here, it will say create project. Just click on that so you can start creating a new project, and we're gonna enter a name for the project. We're going to call it a blockchain, because we're building a blockchain. We're going to accept the terms and conditions, and we're going to continue, right? And you can allow Google Analytics, don't really care, and select an account. Let's create a new account over here, and we're going to create an account that's called Scholar Online, like that. All right, and the analytics locations. This is also depends really on your preference. Obviously, the closer it is to you, where you're from, and also understanding the regulatory environment of the country that you're choosing. Because I'm in Africa, I prefer working with European countries, but I think they have South Africa here as well. There you go. And use the default settings. That's okay. I accept analytics. Move on, and then immediately it will start to create your project for you. When your project is ready, click the continue button to continue, and then you will be immediately on your project dashboard, where you can do a lot of things. Now, the way the dashboard is organized, you'll see on your, as usual, on your left hand side, you can navigate through your database over there, or your dashboard, and at the top there's a minor navigation. But what you want here is to select a platform to get started. Okay, so you can build your Firebase in order to get your SDK. you need to understand, you have to, sort of tell Firebase, are you building your application on iOS, on Android, or on the web? Okay, so we are going to be doing a web application. So we're going to select the web version of it. And so you're going to give it a name to register the app once you've done that. All right, and we're just going to call this the blockchain application. Set up Firebase hosting. No, that's not important. We don't need to do that. Okay, so the Firebase, so you'll get this object that you can work with. But for now, I'm just going to leave it. I'm going to go back to the Firebase console because there's something we need to do first. All right, so we're going to just refresh this. And we need to set up, we're not using authentication on this application, but we want to use the database, the real-time database. So we want to be able to specify that because we need the database to get started. So there are different types of databases I've got on Firebase, okay? Storage is really good for storing images, videos, and all sorts of things. Real-time database is the original database that Firebase had, but I know they've upgraded and updated it to Firestore database, which is much more sort of flexible and efficient. And if you had to choose anything from scratch, I would go with Firestore. But the problem with Firestore is that we are using Python to develop, and I don't have the time to go through the whole, SDK and integrating with Firebase based on their native code. So what I'm going to be working with is a library that is called Pyrebase, okay? So this library has been created to sort of integrate your Python application with Firebase. And in order to use this library, you just basically have to install Pyrebase. And once you've installed it, you'll have your configuration on the other side, and then you can already start talking to the database with simple lines of code, So if you wanted to just create authentication, you just do auth blah blah blah, So this is the easiest way to work with Firebase, all right? And I'm going to use this Pyrebase, but Pyrebase does not have Firestore in it. They haven't upgraded it. I think the people that are maintaining it have sort of given up on it. The last time, the one I'm going to be working with is a fork of the original Pyrebase because the original one actually has errors now, doesn't work really well. So this is really like a quick fix solution to working with Firebase. And so I'm going to use that. And as a result, I can't use Firestore because Pyrebase hasn't been developed with Firestore yet. It only works with the real-time database, okay? So go to the real-time database over there, all right? And just create a database. And then when you create a database, you have to choose a location. All right, so you have United States, Belgium, and Singapore. I think I'll go for Europe. I always pick Europe over the US. And then you can start in lock mode or you can start in test mode. So this is very important when you select over here. Lock mode means, the rules and permissions of writing to the database are going to be locked, and you have to specify who has access. Does the person need to be authorized to be verified before they can save anything into the database and so forth. So I'm going to start in test mode, and you'll see as you do test mode over there, you can see that, a read-write permission is all available, which means, you don't even have to be authenticated to read or write onto the database. It's an insecure way of creating a database, by the way. But for the sake of our online tutorial, I'm going to just do it this way so that I don't have issues writing to the database without authentication. And then I'm going to say enable, okay? And you can always double check your rules or edit your rules directly on the Firebase console, because once you've created your database, and here it is over here, I've created it, you go to the rules, you can edit the rules here, so right now you can see what the rules are, okay? Read on write is allowed. Your database is good to go, all right? And then once your database is good to go, you need to then go get that object. Okay, we don't need authentication. Let's do authentication because it's going to give us an error on the other side, all right? So get started with authentication. Even though we're not using it for this specific application, I think the Pyrebase, library checks that you have those permissions allowed inside of your SDK, and if you don't have them, it gives you an error that, okay, you need to allow authentication, even though you're not going to use it. I'm just going to set it so I don't get an error with it. So I'm going to say enable email and password authentication. I'm not going to enable that. So it will just be this one that's enabled. All right. and then you'll be able to see every time a user is created, you'll be able to see them over there. And that's all you need, all right? So after you've done all of this, we need to then go back and get that object that allows you to get the sort of the configuration of your database so that you can work with the database. Okay, there it is. So you navigate to project settings, general, all right, and then you will see at the bottom over here you have this item called this is your SDK configuration, all right. So you just need to copy that, all right. This whole object, you just need to copy that, all right, and go back to your Python, all right, and then you're going to create a new a file. All right, in this new file, we're going to call it Firebase. We're going to call it Firebase configuration.py. It's a Python file. And then we're going to paste everything that we've copied in here, okay? So we're going to call it Firebase config, this object. We're going to create an object and we just call it Firebase config, all right? And then it's going to be a dict object, and then we'll paste everything inside of it, all right? So it's just some high-level mods that you need to do. All of this needs to be like a dict object, so they need to be in brackets like that. Don't worry, I will delete this project once I'm done with it. So I'm very happy showing my API keys and so forth. On your side, when you do this project, make sure you don't show your API keys to anybody because this is private. Anybody that has access to your API keys can literally write to your database. And if you are creating this and people write into your database, it will make it insecure. So be very careful that this is private information. If you're doing a Git repository, make sure you sort of include this file in the Git, the excluded Git files, which is git ignore, and that you don't include this. People mustn't see this. This is very private. Your API key, your URLs, all of this, you mustn't show to anybody else, or else they will have the ability to write to your database as well, which you don't want, okay? So this is basically how you get your database started. This is how you save information into your database. So I'm going to save all of this, all right, and then I'm going to click save all, and then we can get started with our Python programming. And make sure that you keep the Firebase configuration ready there, and then you can go into your Python file and you can start writing some Python code, okay? So I've retyped it ahead of time to save some time on this lecture, but basically this is what your Python code needs to look like, okay? It's very, very simple when it comes to creating a block, okay? I'm gonna show you, maybe let me put this closer here so that you can see what I'm talking about. Remember on the block, I said you need a block index, you need a previous hash, you need a nonce, you need the data, and you need a timestamp, okay? So we're gonna create a block like it's a dict object, okay? Dictionary object in Python terms, okay? And the first block that we create, which is going to be the Genesis block, we're gonna call the index 1. And then after that, we're going to say the previous hash, because this is the first block. There is no previous block. So the previous hash technically is as nothing, or you can put anything that you want over here because there's no previous hash. When we create block 2, we will need the hash of block 1 to go into this section that is called previous hash, because this is what connects the blocks together. The hashes connect the blocks together so that you know which block came ahead of that block. You record it in the data of the block that you're currently in right now. And then we're going to have a number that is called a nonce, okay? So for now, don't worry too much about what is a nonce. Basically, a nonce is just a random number that is used to calculate the current hash of the block, okay? And we will do that when we get to the proof of work section, when we're discussing how to get the proof of work, which is basically what this type of blockchain is based on, proof of work, all right? And for now, just pick any random number and put it over there. In future, we will calculate this number to get a certain hash All right, but we'll do that at the end. And then the block data can be anything really. So I'm going to put a string in this sense and say the block data this is the Genesis block of School Online blockchain. All right, and then I'm going to create a timestamp, and the timestamp is basically datetime. All right, datetime now, which is the current time right now, and then we're going to save it in string format, and then we're going to put it in there. So basically this block is a dict object, a dictionary object, which contains the index, the previous hash, the nonce, the data that you're putting in the blockchain, and the timestamp. All right, and then once you've done that, when it comes to blockchains, there's a specific way you have to save it. You can't just save it like, okay, block, go into the database, we are saving you. Okay, these are very, very specific things you have to do. We have to encode the block before we save it. All right, because you need to hash the block, so you have to encode it before you can hash it. All right, and we have to encode it in a certain way because the data that we save is going to be hashed, and we're going to get the signature of that data. You know how Python works. It can rearrange the dictionary objects, so it can put the index before the nonce, and then next time it can put the nonce before the index, and it can rearrange the order of your keys. And you don't want that, because if the order of the keys got rearranged, all right, the data signature would be different. All right, so what we do is that ahead of time, before we save it, we make sure that we sort the keys in a certain way. So we sort the keys, and every time they will be sorted in the same way, and then we encode it, and we code that block so that when we hash it, all right, and we get a data hash, we know that even next time the same block encoded the exact same way, sorted the exact same way, will produce the same hash. Because even if you put a comma at the end of the sentence, the block hash is going to be different. Right? So you need to make sure you encode it. You need to make sure you sort the keys out in a specific way every time, and they must be sorted out the same way every time, so that the hash will be the same. The signature of the data will be the same, because a hash is very, very important. It's what identifies. It's that a fingerprint, and we use that hash even in the next block. We need the previous fingerprint of the previous block to connect the next block to the old block. So this is very, very important, these two lines of code. All right. And then that hash, it goes into the block as well, and then you return the block. Okay, so this is the simple code for generating a block. All right, so we're gonna run this code in our Python virtual machine. All right, so let's get ready to run this code, and then you will see what is produced when we run this code. Okay, so I'm going to go into my virtual server. You'll see at the top over here, there's nothing I need to install, because all of these are already included in by default in Python. All right, so I can basically just copy this whole code, and I can go over there, and I'll create a file called nano. All right, what did we call it? We call it block.py. All right, nanoblock.py, and then we can save that code that we put in there. All right, so this code is exactly what we had over there. Those are the imports. This is the block, and we can save this file in here, and then you can then close the file by tapping Control X, and then you can run this line. Okay, and how you run code is just saying Python. All right, Python, and you paste block.py, so it will run this using Python, and you make sure you do this with your virtual environment switched on, and then you click enter, and it's very, very quick. You see, it was just a split second. This is your initial block. Okay, so it's a dict object. You'll see the index there is index 1. The previous hash, we specified it as 000. The nonce is 456. The data this is the Genesis block for the blockchain. And then you'll see the current timestamp, 1124. All right, 1123:59. This is when we generated this block. And then this is the hash. Okay, so the hash, this is your data signature. Okay, the data signature is it's 456. All of that is a signature of this entire block. All right, I'm going to show you something quickly. I'm going to go and nanoblock.py and open that file, and I just want to come to the bottom here, and I just want to show you how sensitive the signature is. Just put a full stop at the end of your sentence. All right, and then save that by tapping Control X, enter block.py, and we've just changed the data by just adding a single full stop at the end of the data. The hash is going to be completely different. All right, So let's click enter, and you'll see over there, once you redo the block.py, you'll see that hash was 456CB is 0409. It's a completely different hash to the hash that you have over there. So every time you change any information inside of your block, the hash will be completely different. But in this specific case, let's say we don't add a full stop, we don't change anything, we just run it again. Okay, and the hash is completely different because the timestamp is different. All right, so every time even if you ran it without changing the data itself, the hash will be different because the timestamp is different. So this is the power of the security of the blockchain, because you can never reproduce that hash again, because you can never go back to that timestamp, that immediate split second again, and produce that data again. So every time the hash will be different if the timestamp is different, unless if you put in the same timestamp, then the data would be exactly the same. So this is the power of the security of being able to confirm that that data was specifically that data. Because if you went and you rehash this with that timestamp, you will get the same hash. Okay, so this is very important concept to understand when it comes to blockchain programming, is the data signature and the data fingerprint, all right, which is the hash that goes into the block itself, because we're going to use that hash in the next block and so forth. All right, so that's the first part done. You can take a breather, chill a little bit. You have just written code for your first block of the blockchain. Now, the next thing that we're going to do now is, obviously, once you create this block like this, it doesn't help you if you're just going to print it out. We have to save it, and this is why we did the Firebase database. We're going to save this blockchain in Firebase. All right, so very quickly, I've written a different file over here, and it's exactly the same file, except I've added the ability to save this block into the Firebase database. All right, so this is how it's going to look like, right? So we're going to need a Pyrebase. Okay, so Pyrebase, you need to make sure you install Pyrebase, and Pyrebase, we're going to install it from this library here called Pyrebase 4, and I'm going to put this link in the description below. Don't do pip install Pyrebase. The old Pyrebase is not maintained, and it's got some errors. You're going to have some problems later on. There is a fork of the old Pyrebase that has been forked by this very nice gentleman over here, and he has fixed those sort of issues with the old Pyrebase. Okay, so if you want to work with Pyrebase, you have to use this fork, which is pip install Pyrebase 4. Okay, so you just go to your virtual environment and you type pip install Pyrebase 4. So I've already installed this, and I'm not going to run this again, but in your specific case, install Pyrebase 4. Don't install the normal Pyrebase because it's got errors. It's not really well maintained, and this is really well documented. Once you install it, you're going to create a config object with all of this information, and this is that information that I got over here under Firebase configuration. It's called Firebase config. So in this specific case, I've already made sure that you, from the Firebase side, when you do this, if you don't want to have an error, because I've tested this and I've seen all the possible errors that you can have. All right, when you get this config, make sure you have activated your real-time database. So make sure your real-time database has been activated. Make sure your authentication has been activated. Both of these must be activated, because when you get your object, so once you've activated all of this, you go into your settings and you go into your project settings and you scroll to the bottom and you get this object. Get this object after activating these two things, because if you get it before, it doesn't include some of, like it won't have the database URL in it if you haven't done the real-time database activation yet. And if you don't have the database URL, when you're trying to reinitialize Pyrebase, it's going to give you an error because it doesn't find the database. All right. So make sure that the auth domain has been activated by activating authentication, and the database has been activated. Then come back and copy this object. All right. That's very important. And also, you're going to have an error and you won't know why. Right, so once you've done that, you have your config object. You go into your Firebase blockchain application. To initialize Pyrebase is very easy. At the top there, make sure you import Pyrebase. Then you say Firebase Pyrebase initialize app, and you enter your config object. Okay, so I'm not entering it here because I remember what I told you. This is very, very important that you save it in a different file. So I've saved it in a file called Firebase configuration. Make sure that file name, whatever the name you call it, don't use my code. Call it what you want to call it. And whatever you've called that file, make sure you import it at the top. So you import it at the top based on what you've called it. So I called mine Firebase config, not this one because I'm using different config over there. So Firebase config is what I called the file. So import that file at the top. And then inside of the initialize app, make sure you just call it, you call that same file which you've imported at the top, dot the object name. And the object name here was Firebase config, which is this object name over there. So call it that object name dot the name of the file, and you make sure the file is imported at the top. This is very, very important. You have to get this right. Once you have this, you just you're going to create a database by saying database is firebase.database, exactly like that. So you only need these 2 lines of code working with Pyrebase. This is why I work with Pyrebase. These 2 lines of code, you're ready to write to the database. Then the rest of the blockchain code doesn't change. You have your block, but I've changed the data a little bit. Instead of having one string object, I'm gonna save another, like a JSON object in there with a name, a surname, ID number, whatever it is you want to save. This can be anything. This can be a contract. Okay, so the smart contracts are built this way. Okay, so they are saved inside of the blockchain. So this data can be anything. It can be an object, it can be a string, it can be a number, it can be a contract. You save it in there, and then so under block data, you put that data that you saved in there, and then everything else remains exactly the same. That's the only thing I've changed is the data type. Instead of a string, I've put that data type, and the encoded block, everything remains the same. So this code over here is exactly the same, except here I've added the dict object instead of that. All of this remains the same. I don't change anything. And then I just added that 1 line of code at the end over there, which says db child blockchain child new hash set block. Okay, so this is sort of the code that you need to save this block into your Firebase database. Okay, you call this db, which is that db that you initialize at the top. A child blockchain, so you're creating a new database called blockchain. If you did, a new table inside of a database, a new table called blockchain. If you already had it, it will not recreate, it will just add on to that same table. And then a child, you decide sort of what reference is going to be, associated with your table. So this is like your unique ID for your table. All right, so I'm going to use a new hash because I think it will be unique and it's good. I'll use it, be able to call the information later on. And then you set the block. Okay, so I'm going to set this block into that database, and then that's it. All right, so we're going to copy all of this. All right, and I'll create a new Python file called firebase.py. All right, so you go over here and you just say nano Firebase, like that, and then you're gonna paste all of that in there. All right, then once you've done that, you close that. Let's not save anything, and then we're just gonna run Python firebase.py like that. Okay, so you say Python firebase.py. Right, this time it takes a bit of time because it's calling an API and it's going into the Firebase database. And if you don't have any errors, it means it has saved everything nicely into the Firebase database. All right, and you can see this is your block. Everything else looks exactly the same what we did there. The only difference with this block is that as we're creating it, we are saving it into a database. Okay, so I'm going to go into my Firebase database. And so this is the blockchain a table that was just created now. And if you open it up, you will see that this is the reference. So this is the hash. Okay, so you're going to open that up. And you'll see, so this is the block. Okay, so it saved the ID number. Okay, so what it did over here, it only saved the data, not the block. So let's see. I think I didn't, let me just open up nano firebase.py. Yeah, this is a problem. So you need to set the block, not the data. Okay, so I changed it on the code, but I didn't change it over here. Okay, so we need to set the block in here. All right, instead of the data. All right, so let's X save Y. Let's run this again. Let's run Python firebase.py. And let's go over there back to the blockchain table. And this is a nice thing about the Firebase database, even if your data structure changes along the way. So you'll see over here the data structure was ID number and so forth. And this data structure is going to be slightly different because now we're setting the block. We should be setting the block, not just the data, because the data is there in there, all right? And it's another object. So this data object is that same object over there. But I want to set into the database not just the data object, I want to set the whole block. And the whole block includes the index, the nonce, the previous hash, the timestamp, and the current hash. And this current hash is also the reference that we use to save the table. So the nice thing, you can see this was the initial row in this table. This is the next row. So Firebase is really flexible in that sense that you can actually even change your data structure as you go along because you're saving an object. You're not saving rows and columns. So the rows and columns don't always have to match each other. Okay, they can be different and it will work. And this is really revolutionary. I mean, I love working with this type of databases. If it wasn't for the cost, I'd probably use Firebase all the time, right? So, so basically, this is it. You've created your first block. You have written code for it. You have saved it on a Firebase. And what else is there left to learn? I think in the last part of this lecture, I'm going to show you quickly what is proof of work and how to incorporate proof of work in your database design, all right? So let's go into the code very quickly and discuss proof of work, all right? Proof of work, what is it? It's basically proving that you've done some work, all right? So if you think about a blockchain like cryptocurrency, like Bitcoin, right? If it was this easy just to add a block, right? Because Bitcoin rewards you every time you create a new block, it pays you to create a new block. This is why people go into the platform and create blocks and develop hashing machines and spend money investing in all of this electricity and all of that because they pay you for maintaining their blockchain. So if that's the case, many people would want to do it because they get paid for it. Now, if many people came in there and they all started to hash and mine blocks every second, because it took us a split second to do this mining, blocks would be created every split second, and you wouldn't be able to manage the inflation because you would be creating newer blockchains, newer and newer coins, and you would have an issue with inflation, first of all, but you might even have blocks that don't have any data in it because you are mining it every split seconds. You need time, first of all, for new transactions to enter the pool so that you can add the transactions into the database. So there needs to be something in place from the coding perspective that manages that time, that it takes time to create a block so that there's time for transactions to be created, but also you don't just mine every 2 split seconds and create new, because every time you mine, you're creating new Bitcoins and you're creating new, a currency into the industry. And if you did it very often, you would have a problem with inflation, which is a problem with like creating money, right? Inflation. Now, the way they handled that problem was to make it difficult. They introduced what they call mining difficulty. So they created difficulty in this process of building a block so that it's not that easy to build a block, so that you have to invest effort and time in creating a block by creating a problem that needs to be solved. And that problem takes time to solve and takes computing power. So while you are taking time to solve that problem, at least you're giving time for the transactions to be created, but also you're solving the inflation problem. So I think in the Bitcoin blockchain, the time, they've solved it to be 10 minutes between block creation, and every blockchain has its own period that they think it's important, right? And what happens is that the blockchain itself will adjust the difficulty so that it always sort of manages the time to be around 10 minutes between block creation, right? So let's go into the proof of work. Maybe it will make sense when I'm explaining it in very simple Python code, by the way, all right? So this whole process of creating a block, we need to build a loop into it, right? And that loop must be a loop that takes time to finish going through that loop, all right? And it takes computing power as well. It takes time, it takes computing power, because it's like mining. It's called mining for a reason, because it's an intensive process. It's a time-intensive process. It is an energy-intensive process. It's a computing-intensive process. Now, in simple coding, we're going to be using this is why we have this variable that is called the nonce. All right. So this variable that's called the nonce, in the previous versions of our block, it was just a number that we decided was 456. Okay. In a proof of work blockchain, this number is not just a random number, it's a number that is calculated. All right. So the computer or the code calculates this number to get a certain result. So it's like a problem. We introduce a problem into this whole process. We introduce a complexity, and it's a man-made problem, but it's created so that the computer does some work to solve this problem. All right. Because we want this whole thing to take time. I mean, technically, you could say, if you wanted, you could just say time.sleep, and sleep for 10 minutes, whatever, but we don't want to do this because this is overly simplistic, right? Because we want to adjust this over time, all right? So instead of saying time.sleep and just making the thing wait, we're giving it work to do, all right? And the work that we're giving it is we're saying, okay, we know you're going to calculate the hash, right? Remember, this is the calculation for the hash, which we had over here. And then it just sort of like, it hashes this whole thing. Encoded block, hex digest, and then it gets a new hash, right? So we know you're going to calculate the hash, right? But when you calculate the hash, we want you to calculate a certain hash. So we want the hash to meet certain requirements. And so you will calculate this hash until it meets these requirements. And because we're giving you these requirements, it's going to take you time to meet them. And that's where the difficulty comes in, right? So what we're saying is, we want you to calculate this hash, but when you calculate the hash, this hash must meet these requirements. And the requirements it must meet must be that the hash must start with 5 zeros. Okay, 1, 2, 3, 4, 5. These requirements can be anything, by the way. It's just requirements I've selected because I think this will take just a couple of seconds to solve because I don't want to wait for 10 minutes for this thing to be solved, right? So what I've told it is, I want you to calculate a hash. The hash must start with 4 zeros, 1, 2, 3, 4, and a 9. And then it can be anything after that. So the first 5 digits, so this new hash, once you calculated it, this new hash, the 5 digits of the new hash must start with 4 zeros and a 9. And if that's not the case, you must calculate again. So you must keep recalculating the hash until you find a hash that starts with 5 zeros and a 9. So this requirement can be anything. Like I've seen cases where it's like a 0x, 0x, 0, whatever, 0x, 0. It can be anything. And the more complicated it is, like if you make it 6 zeros, 7 zeros, more zeros, the more zeros you add at the beginning, the longer it will take to calculate it because you're making the problem more complicated or harder for the computer to solve. So you can make this problem as complex as you want for the computer to take time solving it. And in the process of it taking time to solve it, it means the block is going to take time to be mined. And this is how you introduce the mining difficulty into the whole. This is the simplest way for me to explain it to you. All right. And for a beginner blockchain development course, this is how we're going to do it. We're going to do it with like 5 zeros, okay, and a 9. And we're going to say, calculate a hash, but I want the hash to have 4 zeros and 1 9 at the beginning of the hash. And if that's the case, then I'm good to go. But if you can't get 4 zeros and whatever, calculate again until you get it. So this whole process now takes time. Okay. So, and then after that, save it into the block. Everything else is the same. The only thing you've changed is a calculation of the hash. And this is where the nonce comes in, because if it's not the case, you add a new number to the old nonce, and then the nonce is different, and because the nonce is different, the hash will be different, and then it will recalculate the hash. So the nonce is the variable inside of this block that you're changing. And every time you are changing the nonce, but remember the timestamp is probably also changing. Okay, no, the timestamp won't change because you would have added the timestamp once off. Okay, so you're only changing the nonce, so you're giving it leeway to say, okay, the data will be different. Okay, because the nonce is different, so the signature must be different. So every time, keep sort of incrementing the nonce to get a different hash until you get a hash that starts with 4 zeros. So I think maybe let's put this code into practice so you can see what we're talking about. Now, we're going to create a new file called proofofwork.py. All right, so we're going to say nano proof of work. All right. And this is it. All right, so this is a proof of work. It's the same code in there. Just paste it in here, and you've got the mining proof of work. Sort of, it's a loop. You're just adding a loop into the block creation stage. All right, and then we're gonna do all of that. And then once you've done that, let us now run this code, and you will see. I just want you to pay attention to how long it took us to run the other blocks, and how long it will take us to run this block. If you have a timer, put your timer on and calculate how long it takes for this to get the right nonce, okay? So you're just going to click enter over there. You see, it's taking a bit of time. It's taking a bit of time. There's a couple of seconds are passing, but I didn't make the problem too complicated. So it's not going to take minutes, okay? It's taking in some, but you can see it's taking time. So what it's doing now is going through the hashes. Okay, it's finally finished calculating. All right, so it took some time, and I tried to make it not too complicated because I don't want it to take minutes. I want it to take seconds, so you can see me doing it on camera. But in your specific case, depending on how complicated, how long you want the block calculation to be, all right, you can make this problem even harder. You can even add an extra 0 over there. It will take even longer, okay? So you'll see now the previous hash is still 000. The nonce is now different, okay? It's now 692506. So basically, it went from a nonce of 456. It kept incrementing until it reached 692506. So this is pretty much, it incremented this many times to get the nonce that gives the hash that starts with 4 zeros. You'll see over there, the hash started with 4 zeros and a 9. So the data was the same, the timestamp was the same. The only variable it could play around with was the nonce. So you kept changing the nonce until you got the hash that started with 4 zeros and a 9, okay? So we can do this, we can change this a little bit. Let's play around with this a little bit, and let's make this the first 6 digits, all right? Let's make it 5 zeros, all right? Not a 9, let's make it like a 2 or 3, right? So let's say we want to get 5 zeros and a 3, the first 6 digits. So let's do it like that. All right, so you can do this, play around this in your own time, and then you'll figure out like how long you want to do it. You can change it like that, but actually to save time, I'm not going to do it in this because I don't know, I've never tested how long this will take, but you can definitely play around with it in your own time until you find the period that is sufficient. But this is basically, in very high level terms, what proof of work is. You give the computer a problem to solve. You make that process take longer. You sort of, it's a created problem. It's not a real problem. It's a created problem, but the purpose of creating that problem is that you don't want blocks to be mined every split second. You want the blocks to take time being mined so that it gives time for the transactions to be created, but it also does not, because in terms of a proof of work blockchain, you don't want a Bitcoin to be created every split seconds. You want them to create it only every 10 minutes. That is why the proof of work has been introduced. And the way the Bitcoin blockchain works as well is that this difficulty itself is also a variable. Okay, so this difficulty adjusts to get the mining time faster, because what happens with the Bitcoin blockchain is over time, more and more miners are introduced, so more and more computing power. So my computer has a computing power of I don't know how much, but if I had a more powerful computer, it would solve this faster. So if it solved it faster, the time would reduce from 10 minutes to maybe 5 minutes. But we don't want that. We want the time to be 10 minutes. So what does a blockchain do? It increases this difficulty. So you'll hear them talking about, oh, the difficulty has gone up again. The difficulty has gone up because the hashing power goes up. Okay, so the hashing power is basically the computing power, the power that it takes to produce a hash. You know, the hashing power, the power that it produces to create the hash. That's why it's called the hashing power. Now, if I can create a more powerful computer, that powerful computer will solve this faster, which means that time will reduce from 10 minutes. And I don't want that. I want the time to remain 10 minutes. So inside of this type of blockchains, they've built in the functionality and the ability for the blockchain itself to adjust the difficulty. So when it realizes, good, I know these people are now solving this in like 2 minutes because now they've got more powerful computers over time, I'm just going to make this problem harder to solve. So it just increases the difficulty exponentially. Then it takes longer, then it takes the time back to 10 minutes. All right. So over time, in real life blockchains, this difficulty is adjustable, because ultimately what we want is just the time to solve a block to be 10 minutes. All right. So guys, I hope you learned a lot, but there's a lot to learn in terms of blockchain programming. What I've shown you here is very, very basic, high level, just creating a single initiate block, a Genesis block. There's much more. How do you create the next block and the next block? And how do you start building transactions into the blockchain? And how do you sign transactions? And how do you do all of that? How do you introduce the elliptic curve cryptography? We've got a full blockchain course on our Scholar Online website. I'm going to put the link in the description below. Go there and learn more. I think it's like a couple of hours, 10 hours or more of just learning programming, but I take you through it step by step, in definitely more detail than I've done here, and you need time to go through it, but think about enrolling for that course if you're really interested in the kind of stuff that I'm teaching you here, and we'll see you again next week.